going to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, and you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi, my name is Robert Sabourin, and I look forward to speaking at TestCon Europe 2020. I'm from Montreal, Canada, an independent consultant, been involved in software engineering since the dawn of time, wrote my first code in 1972, first commercial release was 1982. I'll be talking about testing in the dark. How can we do high value, effective testing with almost no information at all about the product we're testing? I look forward to it. Take care.
Hello, this is Rob Sabourin from Montreal, Canada. It's an honor to speak at the conference in Vilnius at this time. Just to let you know, right now it's quite early in the morning in Montreal, and we're enjoying a beautiful sunrise. As I look out the window, all of the leaves are multicolored, falling from the trees. The wind is blowing. Everything is beautiful, except that everyone is telling me I should go back to sleep. It's too early. So I'm here to talk to you about testing in the dark. You'll see on the first slide here, I've got my credentials and email address. After this presentation, if you want more details about it or examples or case studies, please feel free to email me at these email addresses. For example, robsab@gmail.com. I'm delighted to answer your questions and share and complement what's in this talk. The talk is motivated by so many projects that I've been called upon to work on where I have actually no idea whatsoever what the product is supposed to do. I get a piece of software thrown at me and I'm told, Rob, test this. And I have hardly any information about it. Sometimes that information is so hard to figure out that it sort of makes you really get angry. So why am I wasting my time trying to do this type of a project? Other times, it's just basically something that's obscured because you're testing or you're beginning something that's out of your comfort zone. You know, if you're testing an API and there's no user interface and you're used to testing a user interface, your first API is going to be testing in the dark, really. So that's we're going to talk about strategies for testing in the dark and some experience reports I have on the subject. Testing in the dark, how to do practical, useful work in the dark. Now, people attend presentations like this or read articles about this because they're suffering. There's some sort of pain that they're trying to resolve. Well, I want to say that I have learned something important. I've learned something important. When I'm testing in the dark, when I have very little information, and I realized how I felt emotionally, I felt very angry, I felt very upset, I was very anxious, very nervous. And then suddenly it occurred to me, and this is through working with some very, very interesting mentors over the years, that when I'm being asked to test something in the dark, it's because people trust me. It's because they don't know that they're asking me to do something that's almost ridiculous or impossible. They don't know. They need knowledge. They trust I can give them knowledge. And I always, nowadays, I always start with that trust, with that relationship. And I said, aha, I'm being asked to do something. It sounds stupid from the outside. It sounds incomplete. It sounds vague. But if the person who is asking me to do this had the answer, they would be able to do something else. So I look at this and saying, I have a fantastic teaching opportunity every time I'm asked to test in the dark. And I also have built up over the years many, many different, if you will, many different strategies to dealing with testing in the dark. Now, when I'm, somehow my slide is being skipped here. Hang on a second, please. Just a second. Okay. So when I'm testing in the dark, I don't have a lot of information about the system that I'm testing, but I have some information about who is commissioning the project that I'm testing. So when I'm testing in the dark, who matters? Who matters? Who am I testing for? Different people have different needs. Who is paying for the product? If I know who is paying for the product, I can ask them, why are you paying for the product? What do you expect to get from the product? I can learn. I can learn things that might become very interesting test objectives. If I know who is paying for the development of the product I'm testing, I'll see who's got something at stake. So sometimes the company is paying for development, it's contract development, it's internal, it's development of a project. For me, it's important to know who's paying for the development. If I know this, I can learn sometimes strategies that can guide me. So sort of saying, hey, are you getting your money's worth? Who's paying for all this stuff? They probably have a reason they're paying. They don't just have a big pile of money and throw it at people and say, develop the code. There's got to be some sort of a business reason behind it. And even if it's an open source thing, someone is committing time and energy to this. Someone is putting their heart and soul into this technology. And knowing that, you start understanding the reason that they're developing the software. And then at the very least, you can start testing to see, has this reason been accomplished? And it doesn't matter what the menus, dialogues, controls, interfaces of the software are. It matters basically that the stakeholders are getting the value that they're expecting from the system. So I also want to know who is developing the software and who does matter. And who is going to dictate a lot. First of all, it's going to give me chains of communication. Who can I talk to? Am I really alone? Yes, I'm in the dark. I can't see anything. But maybe there's people that I can talk to. Maybe there's people that I can interact with to get insights, to learn as I go. So if I can talk to the people paying for the software, if I can talk to the people developing the software, I can ask them questions as we go. I can learn and I can be adaptive. As I ask questions, I get answers. I don't just look at the software. I look at the software, I ask the question, I look at the software, and I use feedback to basically help me focus on what matters. Who is the user matters. Sometimes what's more important for you in software engineering is to model what the user does instead of modeling what the software does. So the user might be important. I may have access to users. I can look at the user, I can talk to the user, I can learn what is the user's job? What is the user trying to do here? So who matters? And if I can find and identify user, and some systems, a user might be a programmer. Some systems, a user might be an operator. Some systems, a user might be a subject matter expert. But whoever it is, they're going to use the system. I can learn from them what they need to do with the system. How does this system help them accomplish their job? So who is the user for me becomes really critical. And when I don't have a lot of time, so you can imagine testing in the dark with no information, without much time, I've always learned it's much more important to learn about how the system will be used rather than learn about how the system was implemented. So who is the user becomes for me a really critical thing to learn about. And you got to hunt these things down. These are interesting things to learn about. I'm always challenging So who is the first question, and I love to learn about who, because once I've got a bunch of who's, then I can start asking the next level of questions. And testing to me is about learning. I want to learn about elements of the software, usually learning about elements of what is quality. So it's important for me to know the purpose of this project, the purpose of my mandate. So why matters. Why am I being asked to test it? Now, I might not have any information about what I'm testing or what the requirements are or what the design is, but I may know why it's being tested. Like, why are we being tested? And I had an example where I was being asked to test a editor. This was back in the days when HTML editors were all the rave and everyone was competing to have the best HTML editor. And my company was in multilingual computing, and we wanted to have a HTML editor that can work in 57 languages concurrently. And it was quite an ambitious desire. And to build a multilingual HTML editor, the company needed to start with a non-multilingual one, just a regular one. And they had found this regular one. They were doing sourcing. They found it, and they basically threw it at me. And they said, test this, Rob, test this. And of course, I didn't really have any idea what the software did. I found out that it was a HTML editor, but what is the menus, dialogues, controls, buttons, operations, functions, features, input, output? I didn't know any of this type of stuff, but I did know why. The why I was testing the product was to see if the software was modifiable for internationalization. And if it was, that we would acquire the company. So I was asked to test the software to basically give information to people who are going to buy the company. So now you start realizing, okay, they're not looking for nuances about is the menu in the wrong position, and if you click twice, it doesn't give you the right output, and it's got a weird crash if some bizarre condition happens. What they want to do is know, is it leverageable asset? Is it a leverageable asset? Can we take this? Can we adapt it? Can we evolve it? Can we integrate it? How does it interact with our other products? There was all sorts of things. Once I knew why I was being tested, there was lots of things, lots of strategies that I could start looking at. Maybe the why the software was developed is related to that. It's all really about learning. When I'm challenged to learn, even if I do not know what the technical requirements of a product are or what the design of the product is, I still am forced with having to learn what quality is. Nobody ever asks me, Rob Sabourin, to work on a project to try to contribute to the project based on my personal view of quality. There's a lot of different views of quality. And one of the things that I find that is very important for me when I'm testing is to know what the stakeholders care about quality. So I try to learn, what is quality? Quality could be a lot of things. Quality could be like Phil Crosby, conforming to requirements. That's one view. Quality could be the product is suitable to purpose. That's another view, the Joseph Duran style view. Quality could be delivering value to stakeholders. All of these are possible views of quality. And if they are the views of my stakeholders or some hybrid model or some different view of quality, that's the view that I've got to start challenging the software with. So if they think quality is conformance to requirements and I don't have requirements, I've got to hunt for what are the requirements. I've got to do looking for implicit requirements. If suitability to purpose is the view of quality, then I've got to look at who is the user and what are they trying to do and why, and see if the product meets that purpose. And if it's delivering value to stakeholders, well, I got to look at the product and I got to say, who are the stakeholders and what do they value? So who are the stakeholders and what do they value? So as I said, conformance to requirements would mean my job becomes hunting for requirements. Hunting for requirements is not the same as hitting keys on a piece of software. And this probably would add more value to your project if you can start digging around and trying to understand what are the capabilities required, what are the non-functional attributes required, what are the constraints. So hunting for requirements is sort of like sticking your nose everywhere and acting like a truffle-snorting pig, looking for what the system is required to do. If it's suitability to purpose, what I'm going to do is try to find users. Meet users, see what they do. There's a project I worked on. It was a medical administration project, and it was not converging. It was a crazy project. There were hundreds of menus and dialogues and controls, and we were trying to test. We're trying to test all of the menus, all the controls, all the options, and it was really taking forever, and it wasn't converging, and it was ridiculous. So we looked at the project from the point of view of suitability to purpose. And I personally knocked on doors, met with users, and discovered that there were exactly 27 usage scenarios. So instead of trying to figure out all the menus, dialogues, and controls, we tried to figure out all the usage scenarios. And we learned about usage scenarios by talking to users. And once we had those, we were able to get users to work with us to see if they could do their job with the software. So suitability to purpose is totally different model of testing than conformance to requirements. And all you're doing is changing what the view of quality is. And value to stakeholders, of course, is interesting because value to stakeholders, different stakeholders value different things at different times. And so quality becomes time variant if this is the case. And I basically then I have to hunt for stakeholders. And I love finding stakeholders. A stakeholder I find is someone who's trying to block me from succeeding, right? It's someone that I trip over when I walk down the hall. I discover some of them by accident. But once I find out who the stakeholders are, then I can tell them, hey, I'm asked to test this project. You're the stakeholder in the finance department. What's your view? What do you value about the product? And I can learn from different people about different things that they value, if that's the view of quality. Now, if you take the who, and that gives you a chain of people you can sort of start communicating with, that's always building, right? You'll discover more who's. So your matrix is going to grow and grow as you learn more about the who's. And the whys help you focus and scope your work. Whys help you focus and scope your work to sort of understand and rebalance. But it's an adaptive process. As you learn, you've got to confront what you learn. Does it conflict with why? Check with who, adapt, and go on. It's not something we do alone and in isolation. It's a feedback control thing. Now, when we're testing, we're being given an object to test. So what does matter? What is the thing? What is the object of our work? What problem is the product trying to solve? Maybe we don't know anything about the product, but we can know a lot about the problem that it's trying to resolve. Are there items? Can we find items? Can we find testable objects? And we can hunt for them and hunt for them and hunt for them and find testable objects that are things we can look at and say, or we can observe and say, this works or this doesn't work. So these become, testable objects, items we find. We can look at the system, and then once we identify objects, we can try to figure out what are the variables, what are the conditions, what are the factors that influence this object. Now, again, if I don't know what the object is, I don't know what to look for variables. And once I have variables, then I can look at ones that are coming in and ones that are going out. What can I observe? What can I control? What can I observe? What can I control? And once you've got observing and controlling understood, then you can start actually designing interesting tests. So what helps to dictate the technical technique of testing? And there's beautiful tools, by the way, in software engineering to help you reverse engineer things or study APIs. So you're not working completely blind, right? There's always a little bit of ambient light in the corner. But of course, the more you test, the more light there is, the more visible things are, the more that you can then start coming up with other techniques to plan and focus your testing. So as you're starting, learn, evolve, build knowledges. And I like to use visual models to do that. I'm a big fan of control flow diagrams and mind maps and block diagrams and things to visualize what I'm learning. And I find if I can visualize what I'm learning and sort of share it with others, we can critique it and we can talk about it and say, well, Rob, your model is wrong. Oh, good. Why is my model wrong? And then I can start learning about what maybe I should be testing or what I should be confirming. And if what I learn is different from what people expect, they will point to my model and say it's wrong and say, aha, good. Then we found a bug because the model represents what the software is doing, not what the software is required to do. And I didn't know that when I started. But because I could make the model and share it with you, we can challenge the model. So we're not challenging the software, we're challenging the model. and visualizing it, making a map or a picture is a great way to do it. Now, where matters, I guess, where the environment, where the software is going to run. This becomes fascinating, the environment issues. You can do so much testing by just taking the application and trying to launch it in all the different target arguments, and just to see if it loads up and runs. Basically just can do things. Different language environments, locale, datas, networks, platforms, all of these where things. In some projects, depending on the why, right, this might be very critical, but where will impact, the environment will impact both the method of testing and also the value of testing. If we don't have much time and we don't have much information, maybe we should learn what the real target user's environment is. And if we know that, then we can sort of focus on seeing the behavior of the software in that environment. I guess if you're looking at all these questions, when matters, right? When is this stuff? Is there a timeline? Is there a deadline? Do I have to get this thing finished by Thursday at 2 o'clock? So we have to look at when, issues of when. We can look at the project history, how the project was used. If we get log files, talk to people about what they've done in the past with it, we can start learning about the use of the product, maybe learn about how it depends on other things. Many pieces of technology do not work alone. And we could take it and put it in like a jigsaw puzzle and then change the other pieces around it to learn how it behaves. In the context of testing, of course, when does matter, and sometimes when is a great source of testing ideas. Playing with things like the system clock can let me do things, really wild things with software. But we have to look at when, past, present, future, or the basic breakdown of when. But when does matter in some contexts. Time matters in some contexts. In transactional systems, it's interesting to see what happens if you try to do a transaction and finish it before it starts by changing, for example, time zones. My classic example is to sort of start a transaction when I'm in Auckland, New Zealand, then go on an airplane and fly to Vancouver, Canada, and finish the transaction in Vancouver, Canada. And I will finish the transaction on a clock before I started it. So you get all sorts of interesting behavior problems about that. We look at, if you can't get any information about the requirements of a system, maybe we can get some information about how it was built. And I like to sort of say, if we know how it was built, we can basically look at how it's built to try to identify weaknesses and areas of instability. And if your why is saying, I want to make sure the software is robust, then knowing how it was constructed can tell us a lot about how to try to break it. And the type of testing I'm thinking of is called software breaking. So software breaking is a technique of software based on the work of James Whitaker, where you have you create a fault model of what you're testing based on what you know, and then you apply explicit attacks. And there's actually 4 books written on this: how to break software, how to break software security, how to break web software, and how to break mobile and embedded software. These 4 books all talk about basically challenging the software based on how it was built or how it was constructed, and then you try to break it. So if you know how it's built, you can break it. If you know a little bit about like it was acquired, that means that other people might be buying the same software. So you might have a user community around bought software. That can give you test ideas. I have actually used FAQs on customer support group websites to find out incredible testing ideas for systems that were changed without any information from the company that developed the product. So the user community around purchased software is an excellent source of information, mostly complaints, but still that gives you ideas of potential problems and potential areas of weakness. If I know in the code base, if I know what was changed or integrated, I can basically do focused testing, focused regression testing, which is a technique that looks at the code change and maps it somehow to capabilities to help focus the regression testing. But you have to know it's changed. So I have to know the access to the source control system, access to the log files from the continuous integration servers, etc. I think how matters a lot. If you're testing in a different SDLC, the way you'll tackle a testing problem if you're doing Scrum is very different than the way you'll handle the testing problem if you're dealing with waterfall projects. So I like to sort of say how it, in terms of SDLC can make a big difference. But maybe the biggest difference is context. Context are the factors that influence how people prioritize requirements, prioritize bugs, prioritize technical trade-offs during the project, prioritize focused testing. These are context factors, and there's a bunch of them. There's business factors, technological factors, organizational factors, cultural factors, and you could have process factors, which we might call governance factors. All of these factors may influence dramatically how you test or focus your work on a project. In my experience, I've basically seen projects where one type of testing might not matter at all. Look at the iPhone 4, released by Apple, made more profit than they've ever made in their life, and you couldn't make voice phone calls. They didn't waste time testing voice phone calls. People didn't want voice phone calls. People wanted VoIP phone calls. And there's a totally different market. They were selling to early adapters. So this is a business context factor that focuses the testing. Context factors that are used to prioritize business, technological, organizational, cultural elements of the system can guide you and can help you focus and scope testing. I like to set up a process around my testing, and even if I'm not testing anything with knowledge of requirements or knowledge of technical implementation, I can still start collecting objects called test ideas. So what I try to do is, as soon as possible, as soon as I smell the project on the horizon, as soon as I sense there's something to do, I start collecting test ideas. And I don't just collect them, I triage them. I start taking a big list of potential test objectives, test ideas, and I sort them and I organize them. And I try to always know which ones are the most important based on the knowledge I have. As I learn more about the context, as I learn more about the why, the way I prioritize them is going to be very different. But I start collecting ideas, and basically always have an idea what the priority is, so that I know if I had, to test something, what's the next thing I would test. And this is something that is amorphous. It's going to change as you learn. But if your test ideas are still collected, but the priority and organization of them may change as you learn more and more. And of course, the more you learn, the more test ideas you get. So I like to start collecting test ideas as soon as I hear of a project, but I never, ever, ever want to stop collecting test ideas even after the software is deployed. So for me, it's continuous, and the best test ideas I get are when I'm actually testing. As late as possible now is when I detail and execute the test. So I collect as soon as possible, but I wait till the last responsible moment before I actually detail my tests. I do not want to make detailed test cases and test procedures early on if everything around me is going to change, and if my knowledge especially is going to change the priority of what I do. So I defer, but I don't procrastinate. I defer till what's called the last responsible moment. So collecting test ideas, I try to collect all the ideas I can find of different types. I sort them, organize them, shuffle them, prioritize them. Test ideas for me come from all sorts of different places. Knowledge of what the system is supposed to do, knowledge of what it's not supposed to do, knowledge about its weakness, right? How it can break, knowledge about the where, how it fits in the environment, knowledge about attributes of it, quality factors of it, knowledge about how similar systems or previous projects have failed. If I know how similar systems or previous projects have failed, I can look at how they failed to inspire fantastic test ideas. And this is just a catalog of different types of test ideas. There's a whole bunch of them. I've got descriptions of, I've got over 400 pages written about these different types of test ideas. But there's lots and lots of different types of test ideas. It's not just one type of test idea. There's a whole slew of different test ideas. And the more variety you have, the better your prioritization will be. Now, when we're working with no design, no requirements, right? We can ask questions about data. Will data be shared with other software? We can test around that. We can test around input-output data. Will processing resources be shared? We can look at this and say, okay, what if we consume processing resources? Would that impact our environment? Would that impact our software? What are the users doing? Are the users familiar with the problem? Are the users familiar with the solution? All of these will help you come up with test ideas. For example, knowledge of the type of users, novice, expert, typical users. Different types of users will use systems in different ways, dramatically different ways. And then there's the notion of categories of users doing different activities. Different types of people do different things. And maybe when you're testing the software, there's only one category of users who's going to start using it, and it'll take a while for other ones. So that can help you focus and prioritize your testing. Knowing about configuration and management of the software and the environment of it can help you to focus your testing. So this is all information that are coming from sources outside of requirements and design. Non-functional attributes, environment, locale, language environment, cultural environment. Does the software have a role to play? Does it replace existing software or hardware? Does the software automate something that used to be a manual process, in which case we can look at the manual process that's being automated? Customization, all sorts of stuff. The key thing is to try to identify testing ideas. So while I'm looking at the product, I'm not really trying to say, does it work or not? I'm trying to look and say, are there any interesting questions about the product? So I look for them. I call this reconnaissance testing. I try to find users, test ideas that matter, what users do, what varies, capabilities. I'm trying to do this with reconnaissance. And also, when I'm doing reconnaissance, I look at the other side and say, how do I know if it's working? So I try to discover strategies to assess correctness. And looking at other products, as I said, projects failing. I try to make an inventory of what people claim the product can do. These aren't requirements, these are claims. And sometimes it's easier to find claims than it is to find requirements. But I can inventory them, and then I can sort of come up with test ideas relating to claims. Assessing correctness can be done in all sorts of different strategies, inspired maybe from American game show Who Wants to Be a Millionaire, where we have lifelines that help us answer questions that we don't know the answer of. For example, you can have call a friend in the Who Wants to Be a Millionaire. If you don't know the answer, well, in software engineering, that means consult a subject matter expert or a test domain expert. So when you're testing in the dark, try to find a subject matter expert, and they can maybe help you to assess correctness when you need to. Same with the test domain expert, when you need to. 50-50, eliminate the incorrect answer. This is from the game show. If you eliminate the incorrect answer, whatever's left must be the correct answer. This is from Sherlock Holmes. If you eliminate the impossible, whatever's left, no matter how improbable, must be the truth. And we can base this on rules of thumb, guidance from rules of thumb. So, for example, you don't know what the correct answer is, but I know it must be bigger than 100, or I know it cannot be negative, or I know the color can't be green. So you have things that are rules of thumb to help you eliminate the impossible. And then there's also team-based approaches based on wise crowds. Check the book, The Wisdom of Crowds by James Surowiecki on the subject. And what this is a way to consult peers, learn from your peers, and consult them when you have a conundrum. There's a whole slew of heuristics that you can apply to testing. If you don't have your tests designed in advance, you can still design them based on heuristic models. Heuristics are common sense rules of thumb that basically help increase the probability of learning something, of solving a problem. Heuristics are guides to your testing. They're rules of thumb. They're fallible but useful. They're not always going to point you to the right answer, but they're going to give you some guidance. There's all sorts of fantastic heuristics available in software testing. Also, while you're doing software testing, it's important to have a method that allows you to work in the dark. And I like to use exploratory testing, which is concurrent design and execution of testing and interpreting the results while I'm learning about the system. So as I'm learning, I basically design and execute tests on the fly. I do not design them in advance. And I will use, this can be automated here. It doesn't have to be manual testing. I can use tools to do this all the time. When I do exploratory testing, we start with a charter. So a test idea can become one or more charters. That's your goal. That's your statement of what I want to learn about. And then when I practice this, I do a time box session between 30 minutes and a couple of hours usually, but maybe if it's non-functional for a couple of days. And during the session, basically, I will test the software, learn about it, and then at the end of the session, I will evaluate what I've discovered. So you start off with the kickoff. Make sure the charter is good. Prepare, get environment and everything ready for testing. Run your session. So you test for your time box time, a couple of hours usually. At the end of the session, you gather your findings, what you learned, what you know, and you review it. And you basically usually review it with whoever you kicked off with, maybe the person you commissioned the project, and you review what you learned and you adapt basically and follow up, adapt your goal, reassess your goal, and build basically your knowledge, build your map of knowledge as you're going. At the end of a session, we ask ourselves a question: should I do another session on the same charter, or should I move to something different? So should I move to something different? And of course, as I said, I want to update my models as I go. So here's the sort of idea where I start with a model, and in this case it says mind maps, but it's any visual model of the features, usage, workflow, data, risks, environment, all this stuff I'm discovering. And then I create a dashboard which shows people what I've learned. And I then drive charters to do my testing and provide insights about it as I'm going. And it's an adaptive loop. I'm always learning and sharing, getting feedback, adapting, and focusing. And after a while, I start having a beautiful picture of what the software does. In fact, when I'm testing in the dark, at the end of my session, I sometimes provide the company with more information about how the product was built and used than they even knew at the beginning. So when I'm testing in the dark, you really have to ask yourselves, do I have enough information? So how do you get feedback on that? Is there some stakeholder you can talk to? You can check what users can do, what doesn't work, are the claims met or not met? All this you can provide insights of in some sort of dashboard. And people love dashboards for feedback loops. In testing in the dark, we're working blind, but we're not necessarily foolish. We can guess and adapt. There are excellent methods of solving problems where the first step is to take a guess, and then you check how far wrong that guess is, and you move around and move on, and eventually converge on what matters. So you guess what's unknown, do some sort of check, reality check, adapt based on what you learn. Adapt based on what you learn. And so that, in a nutshell, is the topic, I guess, the subject of testing in the dark. In a nutshell, there's a lot more details and data that I can share with you on it, and I hopefully have about 5 minutes now before the next session where we can hear your questions or comments. And I don't see any questions or comments here, or how to get them on my screen. Do I consider such projects as serious and reliable? Sometimes I'm asked to do things that have value because people trust me. I don't think that such projects are always something that you confront, but I sometimes get products that are not documented, and still I have to work in the dark, so I learn adaptively. I like the joke here about it sounds like you're testing for the mafia. I have had to test for people, to test products that were made by other people to find weakness for competitive marketing reasons, for example. Levels, the question is, what is level of expectations for testing in such conditions? If it's at the beginning of a product, what my expectation is to create a model so that we can converge, provide feedback to stakeholders, so that we can turn the project into a more acceptable project. The question is the risk accepted? Well, the people who are asking me to work in the dark want knowledge. I will provide them knowledge. However, there is huge risk, and I have to mention to them that there is huge risk because there's a lot of things that I don't know. And so the things that I don't know, I cannot talk about. So that's very true. So it's basically also, as I learn more, we can turn it into a more, how can I put it? A more structured project. As you start building models, you can start then testing against the models, and you can subdivide the project and do it in a more controlled way. But still, you start blind. What if the tester doesn't have the required technical knowledge for the project, but has to test it anyway? This is not a good thing. So I would suggest that the testers should identify what they don't have knowledge of, and then whoever's asking them to test it, be very explicit with them and say, hey, I don't know how to do XYZ, or I don't have a skill XYZ, and please help me find someone to pair with who has that skill, so at least I can work. How to work around the anonymous tester has a good reputation if he is okay. So basically, there's questions about the reputation of tester. You have to be trusted by the stakeholders in the cases and the examples that I shared. But you're definitely right. This is basically working in the dark, getting useful information. But is it complete? No, it's not complete. So I would say that what I want to do is, if this is a commercial product, I'll be taking part of the product that I'm working in the dark with, and I'm going to try to illuminate it and set up a mechanism where I can gain more information so that we can have more confidence. Because you're absolutely right. We don't have a lot of knowledge or confidence in these things. So that's it. That's the questions I see. And I think this is the official end time. I'm going to try to get into the tools that have the Q&A stuff. But that's it. So say goodbye to everyone. Okay, so goodbye, people. Thank you very much. It's been a pleasure talking to you and sharing with you today. And please feel free to contact me, and thank the conference organizers. I know with all the challenges of running a distributed conference that it's been difficult, but thank you, and appreciate everyone's support, especially the technical support to get this done today with my incomplete knowledge. Thank you so much.